When real ink bleeds across paper, it has a natural rhythm. It doesn't just move, it reacts to friction and gravity. Our goal is to replicate that physical grace using a digital line. Standard digital reveals often feel weightless. They tend to crawl across the screen at a perfectly constant robotic pace that lacks any sense of momentum. You don't need external plugins to fix this. Every tool required to simulate realistic physics is already built into the native engine of After Effects. High-end motion design relies on simulating the physical acceleration we see in nature, where a line takes on the properties of a weighted object. We start by building the geometry. First, click into the empty space of your timeline to ensure no layers are selected. This prevents After Effects from accidentally drawing a mask instead of a new shape. Grab the pen tool. At the top of the screen, set your fill to none and your stroke to a heavyweight, around 40 pixels. Now, draw a curved path right across your composition. This action generates a new shape layer in your timeline, which stores the vector coordinates of the line you just drew. Inside that shape layer's properties, look for the small Add menu. Click it and select Trim Paths from the drop-down list. Trim Paths acts as the procedural engine for the stroke. It allows us to animate the visibility of the line from 0% to 100%. While the path provides the spatial geography, the Trim Paths modifier serves as the engine that moves the stroke across it. To make the line move, we need to establish specific start and end coordinates on our timeline using keyframes. Move your playhead to 0 seconds and click the stopwatch next to end to lock it at 0%. Then slide the playhead forward to 2 seconds and set the value to 100%. The software now calculates the frames between these 2 points. On the timeline, the physical distance between these diamonds determines the speed of the animation. Dragging the second keyframe closer to the first forces a faster reveal, while pulling it away creates a slower, more deliberate movement. If you play this back, the motion is lifeless. Because the speed is constant, the line has no character or physical weight. Linear keyframes ignore the reality of inertia, the natural ramp-up and slowdown that happens when a real-world object moves. To fix this, highlight both keyframes and press F9. This applies the Easy Ease function. Linear motion is like a car stuck at 60 miles per hour with no brakes. Easy Ease simulates a driver gradually pressing the gas pedal to start and then slowly easing onto the brakes as they arrive at the destination. Your keyframes change from diamonds to hourglass shapes, indicating the velocity is no longer constant. This is a standard starting point, but to achieve a truly organic snap, we have to move past the presets and open the graph editor. Most beginners get lost in the default value graph. To control momentum, right-click the background of the editor and switch to the speed graph. Ease provides a generic baseline of physics, but the speed graph allows you to dictate the exact g-force of the animation. On this graph, the height of the curve represents speed. A flat line is slow, while a steep peak represents maximum velocity. Click your keyframe points to reveal the yellow Bezier handles. Grab both handles and pull them sharply toward the center, warping the curve into an aggressive, steep peak. This shape creates a move that starts slow, whips across the screen at high speed, and coasts to a stop. Compare the standard ease on the left to our custom curve on the right. This sculpted graph provides a dynamic, physical snap. This technique is the foundational tool for logo reveals, cursive text drawing, and high-end infographic data lines. Mastering trim paths and the speed graph translates vector data into a move that reflects the weight and physics of real-world motion.